Hello, everybody. Welcome. Just checking this is
Hello.
rolling on YouTube and on Twitch. Looks good on YouTube. Just double check Twitch is going as well. I never quite trust this technology to do the job you want it to do first time. Let's just double check we're all good. Yeah, it says we're live. Great. I was just chatting to Josh just off screen before we started about how you really need to have a wired connection nowadays for this, because the latency and drop packets that you get on a Wi-Fi connection can be really dodgy. But hopefully we've got a good connection for everyone today, and this will all go well. Hey Josh, it's great to have you here.
Hey, Jeremy. Really great to be here.
So hi everyone watching. For those of you that don't know, my name is Jeremy Walker. I am the co-founder and CEO at Exercism. It's really great to have you here. We're running a year-long series called 12 in 23. It's a challenge for you to come and try 12 different programming languages out through the year 2023. And for March, we're focused on mechanical March on systems languages. And as part of that, we're really privileged to be joined by Josh Triplett, who is the co-lead of the Rust language team, who is going to be telling us about his journey with Rust, how he got into Rust. We're going to be chatting a bit about learning Rust, what it means to learn Rust, how to do that well, some of the pitfalls, some of the ways to accelerate that process. Then we're going to be exploring a little bit about the future of Rust, upcoming features, roadmaps, that sort of stuff, and also talking about some of the governance and the new constitution that Josh and many others have been working on. And then finally, we're going to have a bit of free time at the end just to answer any other questions. So you might have seen other interviews we've done with Jose and Louis. We're going to do this one slightly differently in terms of we're going to be taking questions as we go. So if you actually have any questions, please feel free to ask them as we go. We've got Eric and Aaron from the Exercism team here who will be passing those questions on to us. So we'll be filtering out hopefully the good questions or the best questions, and we can be asking those. So to get started, it would be great to Josh, if you could just maybe introduce yourself a little bit, tell everyone who you are, and then and maybe just tell us how you a little bit about your programming journey and how you got into Rust in the first place.
Sure, absolutely. So yeah, I'm Josh Triplett. I'm a member of several different Rust teams. I'm the co-lead of the Rust language team. I'm also on the cargo team working on the cargo package manager, and the library team working on the Rust standard library. I've been involved with Rust since shortly after Rust 1.0. My journey into Rust was a bit of a multi-stop one, honestly. So I back a number of years ago, there used to be a popular mechanism called Planet that would aggregate weblogs from various different sources, and I would follow things like Planet Debian, Planet Mozilla, and get an idea of like what's behind the scenes from the various developers there. And I followed Planet Mozilla because I cared about Firefox and the future of the web, but they started talking about various other things as well, and there were these mentions of this programming language Rust that I'd never heard of, and looking at it, it was like they had these great ideas. They talked a little bit about ownership this and borrowing that. Then they gave some examples of the syntax, and it always looked very like Perl-like, way too many sigils. This was well before 1.0, and I'm like, this sounds interesting. Maybe in the future it'll be a thing I care about. Then a while later, I was working on a problem related to Git, the version control system. I wanted to build a tool for tracking stacks of patches. Like you send out a 10 patch series for patch v3, patch v4, patch v5. I wanted better tools for managing that. And I started thinking, well, I could put a tool together for this. So I went and looked at libgit2, the standard library people tended to use then for working with Git. And the documentation for it had all sorts of things like this returns an object that you need to call this free function on, and this returns an object that is owned by this tree object, so make sure not to call free on it or you'll get a double free error. Like, I looked at that and my first reaction is I do not want to write this in C. And I had a fair bit of experience with Python at that point. I'd written some pretty extensive projects with Python. I actually ported Python to run in EFI and Grub for unusual reasons. And like I was used to doing weird things with Python, but the problem I had with trying to write this in Python was that I was not enthused about the idea of getting a lot of dynamic runtime errors. I really wanted a language with strong typing for building a large complex project like this. And then I started remembering a lot of the stuff I'd seen about Rust and thinking, wait a minute, ownership, borrowing, where have I seen this kind of terminology before? And at the time, Rust had just shipped 1.0. And it was big and stable, and that announcement had just gone out, and I had just recently seen that and thinking, oh, I should take another look at that. I hadn't done it yet. I went back and looked. All the sigils were gone. One of the biggest, most impactful changes was that the runtime was gone. So pre 1.0, people may not remember this, but the Rust language actually had a runtime similar to Go or Java that had kind of a green thread system, event handling system, and they ripped all of that out pre 1.0. And I think that is one of the most impactful design decisions that was made in the lead up to 1.0, because without that, you'd have kind of one more runtime based, not quite systems programming language. But with that changed, without a runtime, that is what means Rust can go anywhere C can, anywhere C++ can, anywhere assembly can. It is, it's been a world-changing thing that made Rust have a niche that nobody else can meet.
Was that something they always planned to do? Was it sort of something they had on the roadmap, or was that just something that they sort of just one day turned up and said, we've put a lot of time to this runtime, but we're just going to get rid of it? Like, how was that decision made? Do you know?
So my understanding is it had less to do with, oh, it'll be super powerful to not have a runtime. I don't think it was that. My understanding is that it had more to do with right before 1.0, they had a number of things that were not quite ready for the 1.0 stability guarantee, because Rust makes an incredibly strong stability guarantee that if you've written code for Rust 1.0, it should still compile for today's Rust and build and work. And people test that, and it does in fact work. And as a result of that, they took a strong look at the standard library, at the language, at any feature that they weren't certain they could commit to the stability of yet because it needed a little bit more design work. And the runtime was one of the big ones there, that it's not that they didn't want it, it's that it was something that they weren't prepared to commit to the current design of. And as it turns out, asynchronous Rust, which came a number of years later, has a substantially different design than that original Green Threads runtime. And we've talked about changing that design further. And to some extent, we still have the ability to do that, because even though the futures and async system is in the standard library, in the standard library and the language, a lot of the things like an executor, like async std or small or Tokyo, those aren't in the standard library yet. And until we do, there's things we can still improve and before we're ready to stabilize and commit to an API. So all that said, Rust had just gone 1.0, and it was stable. It was making commitments. It looked really exciting. I loved the idea of, well, wait, you don't have a garbage collector and you don't have to call free. So I figured, okay, let's give it a shot. Best way to learn a language is to try a project in that language. And so I started poking at it. The very first thing I did wasn't necessarily trying to write the big Git-based project that I wanted to build. I started out building some smaller things and leaving aside the hello worlds and similar. One thing I had was, okay, I know Git and I know Fuse, and there's great bindings for both of those for Rust. Fuse is the Linux file system and user space mechanism for building a simple file system. And there were great libgit2 bindings for Rust, git2rs, precisely because Cargo, the package manager, used them. So one of the authors of Cargo wrote the Git bindings. So I figured, okay, why don't I build a tiny fuse file system that exposes a git commit as a mountable thing?
Hmm.
So I started playing with that, and most of it was really easy. I hand wrote a lot of it. I, didn't have a lot of functions and structure yet. I used new features as I found them, and it worked perfectly. It was very easy to get going. It pretty much worked on the first try in the sense of once it compiled, it worked. I spent a decent amount of time having a lovely conversation with the compiler about all the ways my code was wrong, but it helped, and the error messages even then were really good,
Yeah.
and they're even better now. But then I started trying to make that code better. I started refactoring it a little bit, like, oh, I should pull this into an object that incorporates the open Git repository and the open fuse handle, and now I have a structure with both of them in it. And then pull out pieces into functions, and all of a sudden I was getting these weird borrow checker errors.
Hmm.
And it's a common experience people talk about of fighting the borrow checker.
Mm.
And I very much had that experience that um, for reference now, the problem I ran into is if you have two fields of a structure and you write functions that like borrow them mutably and then try to do something, there's a common issue in Rust where it treats it as you borrowing the whole structure
Mm.
mutably rather than one field. And that's partly because from a public interface perspective, there isn't an assumption that, oh, you're only borrowing this field, you don't care about that one, because that
Mm.
would be an implementation detail.
Mm.
We are working on ways to make that better, but that's actually still an issue today. It makes some types of factoring a little bit awkward. So I did that. I started, fighting the borrow checker and thinking, well, I know how I'd write this in C or C++. I know that it wouldn't be this hard. I started asking questions and asking around, and I ran into that recommendations of here's how to end up structuring that. And the the advice that I got and the information I got was very helpful in that it was not the mindset that I was used to approaching a new language with.
Mm.
Um, Many people have used phrases like, oh, you can write Fortran in any language, you can write C in any language. The
Mm.
idea being you can take the programming paradigm you're used to and run with it in a new language, and you might slowly learn to be more idiomatic. But at the beginning, you just kind of force it into the shape you expect it to be, and most programming languages will go along with that.
Mm.
And Rust, more so than many languages, doesn't want to go along with that because it has all of this strong type checking, strong structure. It has ways you want to structure your program, and those will be smoother and work better with the compiler. And so the advice I got was kind of listen to the compiler, take it more as a conversation, build things in patterns that it's
Mm.
happier with, rather than trying to force it into the shape that you expect from another language. And I tried to take that to heart, and I ended up building structures that worked better for that and functions and factoring that worked better for that. And that was really a different approach than I'd approached a lot of other programming languages. I started out writing Python a lot like I wrote C, which, considering I was writing Python to drive some really low level
Mm.
BIOS and ACPI and
Makes sense.
EFI kinds of things, it made sense I was using Python as a simpler C with a REPL.
Mm.
And I've done that with other programming languages, and it really changed the mindset I approached Rust with, and kind of fits with the community as well in terms of
Mm.
this is a community that is great about conversations and, welcoming people, but also having some strong thoughts on how people should collaborate. And it worked out very well.
One of the things that I think I've heard you say before is about treating the compiler like your friend, not your enemy, and how
Exactly. Yeah.
that's a mindset to get into with Rust that isn't the case in other languages, maybe.
It really is, yeah. With a lot of languages, it's, okay, compiler, no, really, I'm trying to do it right here. Like, don't get me wrong, it's nice when it catches something that, oh, would have been a seg fault in
Mm.
another language, but at the same time, oftentimes it's, okay, darn it, you know what I meant there. And, like, you're just trying to convince it that your code is correct. Oh, if
Yeah.
I add enough casts, or if I add enough that, like, sometimes you're placating the compiler rather than it really being an error.
Yeah.
And a lot of compilers, especially warnings, they have a lot of false positives. That's one thing Rust focuses really heavily on is
Mm.
every Rust warning should not be a false positive.
Mm. That's
Even
good.
things that we're not confident making an error because, hey, technically your code will work, even if it's just a warning, it doesn't take a high percentage of false positives. Like even if, 5-10% of the time something's a false positive, you learn to ignore it. You learn, oh, it's okay if your code has a few warnings. With
Hmm.
Rust, you learn that every warning is something you want to avoid and fix, and you really want to write warning-free code.
Mm.
And so, yeah, you get into more of this mindset of thanks, compiler, that saved me a ton of work. Like, what
Yeah.
would that have been in another language? How long would that have been to debug? And I've very much had that experience. I went back and started doing some kernel programming recently to enable something I was looking to do with IOU ring, and it was fun and interesting. But boy, did it feel like I was suddenly walking a tightrope over a bed
Yeah.
of knives, and it was uncomfortable after spending so long with the safety precautions of Rust.
It's like
So
you've
hey, I'm
lost a
glad
friend that's walking with you. You're suddenly by yourself all of a sudden again.
exactly. And it's nice that in the future I'll be able to write Rust and put that in the kernel too and
Yeah.
write a lot less C. But so that was kind of the first half of that journey of like, well, here's this thing, and much later, here's this possible thing I might be able to use it for. Let me learn how to work with it. So from there, I had just recently started getting into virtual machines.
Hmm.
And I've been using them for a long time, but I'd started to get into programming with them. And I was learning the low level API of the Linux KVM virtual machine, the dev KVM API. And I wrote an article for LWN on using the low level KVM API with C and assembly. And I was excited about that. And I thought, okay, that's something I've played with. That's a systems level thing. And this was years ago. This was before Cross VM, before Firecracker,
Hmm.
before the Rust cloud hypervisor efforts and similar. And I was just thinking, well, hey, let me see if I can figure out how to do a tiny VM in Rust.
Hmm.
So I started poking at the API, and one of the first things I realized was Rust doesn't have a C-style union. It had um, enum, which from its perspective is an expanded version, less like C's enum and more like a kind of an OR type. You can say, oh, this is either none or it's
Hmm.
something like an option or a result, or they can carry data in their variants. But it was all safe. It was
Hmm.
all like we know what discriminant this union has, and we pick which one, and all of that. And the dev KVM API, like a lot of kernel APIs, had these data structures that were all struct of union of structs. You have
Hmm.
some top level structure. It has an enum saying here's the 50 variations you might have, and then a union of these fields if you have this struct, these fields if you
Hmm.
have this, and so on. And tons of those. And I started trying to work with that, and it was very manual, lots of casting, lots of manual offsetting, felt really painful. So I started digging in and figuring out, well, could Rust have union types? Started having some conversations with Rust folks, started figuring out what that would take, and ended up writing an RFC to change the language. And it felt incredibly inviting. Like I'd barely started programming on this language, and there were people jumping at the notion of, yeah, of course you can contribute to this. And that was exciting. I started building that. I started coming up with ideas, took the better part of a year, ended up unions, because they're a fairly low level language construct and lots of things have to do with structs and enums. They touched
Hmm.
everything in the language. And so the RFC was 25% here's how unions work, and 75% here's how they touch everything
Right.
else. Ended up being a really long collaborative process, exciting, fun, but
Hmm.
long. And one of the uh, most discussed RFCs at the time, because everybody had an opinion on it and
Hmm.
everybody had input and feedback on how it should work. It ended up finally getting accepted, and I got a suggestion. Hey, there's the first RustConf coming up in Portland, even, and I'm just outside of Portland. It'd be an easy trip in. It sounded exciting. I proposed a talk on here's how to do virtual machines and unions in Rust. I ended up pitching, like, it was effectively a talk on the RFC process.
Mm.
And I ended up calling it in order to form a more perfect union, because I couldn't pass up that pun. And I went and gave this talk that was much more a process talk than like, here's a little bit on VMs and unions and C, and here's a whole bunch on the process of contributing to Rust and what
Right. Yeah.
RFCs looked like. And I was absolutely blown away with the response from that. RustConf was such an energizing conference for a first time conference. Like, there were momentary audio issues, and the audience was sitting there like cheering on the, oh yeah, it's going to get fixed, no problem. Like, it was incredibly encouraging, incredibly safe.
Mm-hmm.
And right after that talk, I was really blown away with how many people came up and were like, I loved this talk about the process.
Mm-hmm.
And a couple of those people were current members of the language team,
Mm.
one of whom said, hey, we'd like to invite you to come join the language team. This is an area we don't have a ton of expertise in, low level, like C and systems interfacing, where we want to have a different perspective than we currently have. Come work with us. And the fact that I didn't have a lot of experience was perfectly fine. Like, I'd learn more Rust as I went, and they'd learn more from the perspective
Mm-hmm.
I had, and started doing that. And it just snowballed from there. Ended up getting
Nice.
involved with Cargo later because I was excited about how build systems and packaging would work. I'm actually building a business now about build systems.
Mm.
And so having the ability to interact on that was amazing. Library work was incredible. The Lib's team was revitalized a couple of years ago. Mara is the current lead of that, who put a ton of work into organizing it. And as a result of that, it was really exciting to get involved there as well. And it's just all been this upward trajectory of more excitement, more ways to get involved, etc.
Nice.
Um,
So
I see a couple of questions in the chat, by the way, that I want to get to, but
yeah,
we should
let's
finish this thought.
yeah, let's do those in the maybe a bit more in the sort of in the future bit. I'm interested in like what's the most the thing that you've done most in Rust, that you've contributed most to it, that you're most proud of. Maybe there's not one, maybe there's a couple, but what's something there that you just feel like, I don't know, where you feel you've really put your stamp on Rust?
It's a fair question. So the unions were a big one.
Mhm.
Inline assembly support was one that I collaborated very heavily on. Amaniu was the lead on that one, but I put a lot of work into how that should work, what directives it should support, how it
Mhm.
should be constructed. We were trying to build an inline assembly that, like, it could never be safe, but it could
Mhm.
be as safe as possible and much more structured about a ability to use assembly. So that was exciting.
Mhm.
Um, and like various technical aspects of contribution to Rust that I'm excited about in that way.
Mhm.
But I'm also incredibly excited about like process as well, of how we build and structure Rust for the future. So in that regard, things like a lot of language team process to try to make it quicker and easier to contribute,
Mhm.
very experimental. Like, some of it worked, some of it didn't, but we're trying things and seeing what sticks.
Mhm.
And then getting involved with the Rust governance work as well.
Mhm.
That has turned into something really positive that I think we'll get to a bit later
Yeah,
in this conversation.
I
So
think.
all of those are things I'm very proud of. At this point, the governance RFC is probably the single biggest non-technical accomplishment in
Mm.
Rust, and I'm incredibly happy about that as well.
Somebody asked if the talk you referenced, that first talk you gave at Rust conference, is available online anywhere.
It is. I'd be happy to provide a link to it. Let
Yeah,
me
great.
grab that in parallel.
Okay, thanks. So while you're looking for that, I think one of the things, jumping way back to what you talked about writing Rust like Rust code. Um, Josh and I spoke briefly last night, and it was something I touched on, something I'm really passionate about, and is a big part of the whole ethos of Exercism, is learning how to write idiomatic code, is learning how to write, Rust code that feels like Rust. It doesn't just feel like C being written in Rust. And as you said,
Right.
for Rust, you're almost slightly forced into that direction. But for a lot of languages, I feel like there's a real challenge that people don't try and learn that language in the way it's supposed to be written. They try and just apply their current knowledge. One of the things that we've talked about a lot is the importance of almost unlearning when you start to learn a new language. You always have to you have to take it as like, I can code, but I don't know how to code in this language, and almost like start again from scratch. And it's one of the things that that our mentors, I feel like the value Exercism really add is, you can solve an exercise that's easy enough, but actually solving the exercise and making it feel like really good Rust code, if you're writing in Rust, that's hard. And that's where I think having a mentor, having somebody that can guide you and help you is um, a real value add. Someone just asked a question
Absolutely,
that I
yeah.
saw that sort of links into this, which I think is interesting, which is there's often a lot of reluctance in companies to adopt new technologies. And I think one of the reasons for that is that you don't have those more senior members of the team that are proficient in that technology that can do some of that mentoring back down. Have you
Yeah.
seen Rust's adoption in sort of maybe I don't know, less geeky companies, should we say, more mainstream companies? Have you seen Rust being adopted more into those places? Do you have any tips or any good advice that you've seen for how to encourage
Sure, yeah.
companies to adopt Rust?
Absolutely, yeah. To quickly touch on something you said a moment ago, I think that's absolutely true of people talk about the process of learning like human languages, like becoming bilingual, trilingual.
Yeah,
And one of the big things there is like there's a reason people do it immersively. You talk and try to think in that language. If you get in the habit of mentally translating, you're going to have a really bad time and you're never really going to be very fluent.
yeah,
And the same is true of a programming language. You don't want to be mentally translating back and forth.
no,
So, as far as adoption in companies, I've seen quite extensive adoption of Rust in really amazing places, wildly different than what you might see. Like on the one hand, you see, the obvious answers like the Googles, the Microsofts, the
mhm,
Huawei's, the uh, all of the companies that have 100,000 people or more and have the ability to do a lot of experiments without it being high cost to them.
mhm,
But on the other hand, I've seen a lot of small companies that are either building substantial things around Rust or at least saying we should learn Rust and
mhm,
understand what it is that we have to gain from it and start getting ahead of this. And I think part of it is if you're a company that's like always in crunch mode, always like, we have far too few people and far too much to do. That's not as healthy a work environment. And it's also not healthy from a perspective of you're not going to have time to explore any new technologies
mhm,
or like, sure, in that environment, if you have to ship or your company's going to die, or at least that's how it comes across from, your management chain,
mhm,
then you don't necessarily have the bandwidth to try something new. And that's completely understandable.
mhm,
But if you have any spare bandwidth at all and you have the breadth to try something, then uh, Rust has the potential to trade off. Yeah, you're going to do a little more work up front, learning a language, getting some mentorship, having the senior people on your team forge ahead and figure it out, and then provide mentorship for everybody else.
mhm,
But you're very much trading that upfront cost for so much less cost in the future.
mhm.
Fewer bugs, fewer maintenance issues, less time debugging, easier time shipping once you get used to it. There's been all sorts of like 2 or 3 different studies that all came up with about the same numbers that like 70% of security bugs go away when you start working with Rust. And so fewer of those big fire
Wow.
drills for whatever you're
Yeah.
trying to do. You see all of this information about how much more productive people feel once they
Mhm,
get into it. So you're paying that upfront cost. That's absolutely true. And of course, that's always something we're trying to make easier. We're
mhm.
trying to find ways to make Rust easier, more approachable, more learnable. I would love to hear from many of the mentors on the Exercism team about like what things people have the most trouble with. Honestly,
Yeah.
like please tell us what people have trouble learning and we can figure
Mhm,
out, okay, to what extent does this mean we need better documentation? And
mhm,
to what extent does this mean the language needs to be better so it's not as hard to
mhm,
learn? Because documentation is the second best way to solve that problem, but the best is to not have to document it because there
mhm,
isn't something as hard there.
mhm.
But as far as adoption goes, I've seen it at like there's a company that's building a train system, like locomotives using Rust, and
Mm,
that's a heavily regulated environment, all that kind of thing. There are people working on uh, car automotive systems, and I don't just mean like the super experimental stuff. I mean like you know Volvo is looking at Rust,
Okay,
and this is not a company you expect to make exciting choices.
yeah.
This is
No.
a company you expect to be incredibly rock solid,
Mm.
as long as it doesn't have to do with their, engine emissions or
Yeah.
anything like that.
Do you,
But
I was going to say, do
go
you
on.
think the Linux adoption has helped in this? Do you feel like that's given you more
Oh,
authority? Or?
massively. Yeah.
Yeah.
Yeah, if you take a group of people that are incredibly conservative with their technology choices, who are
Hmm.
very happy with C, or at least have learned to channel it into a certain cantankerousness that people deal with,
Hmm.
then and then they've rejected other languages in the past repeatedly, and then Rust has actually gotten a huge amount of traction.
Mm.
I think that really says something about, like, for all that I said earlier, that you need to, like, learn to speak Rust and be conversant with Rust rather than forcing another paradigm into it.
Hmm.
It's also the case that Rust works really well with other languages. We've
Hmm.
had lots of reports of people using it incrementally with C, port a little bit of
Mm.
C and make an interface to C. There's things like bindgen and C bindgen. Um, People made an interoperable layer with the Qt toolkit, the Qt graphics toolkit. There's wonderful layers for Python. There's wonderful layers for Ruby. There's
Hmm.
50 different languages where people say, oh, you need something to go fast and be native. Drop down and write a module in Rust for your language. People
Hmm.
write Python modules in Rust, Ruby modules in Rust, Ruby interpreter. Like, there's Rust code in the Ruby interpreter these days to
Nice.
do a fast JIT.
Yeah.
Um, so being that kind of glue, that's another thing that is something traditionally you always had to drop to C for. C was the
Mm.
glue that could speak everything, or everything had to speak C or similar. So that's something I'm very happy with as well. And that's borne out in the kernel, where you would think, oh, we're trying an experiment. Maybe we'll write some weird little peripheral driver with it. Or, maybe just the graphics driver for all Apple systems will be written in. Like,
Yeah.
these are not small
No.
things. And you hear the people talking about how they wrote those drivers and
Mm.
how much easier they were and how much fun it was to write.
Yeah.
So I'm not concerned about adoption.
Hmm.
It's always going to be slow and steady, and that's fine. Like, it's
Hmm.
remarkably fast, but, like, I'm never going to chide a company for making a more conservative choice. But
Mm.
hey, next time you have the bandwidth, learn a little Rust,
Yeah.
and you'll be more ahead of the curve.
Nice. There were two questions that came in, both of which I think are interesting on this as well. So the first is, has Haskell's influence on Rust's design been discussed yet? And no, it hasn't. And this is interesting because we've got Simon Peyton Jones is doing an interview in a couple of weeks as well. One of the
Awesome.
creators of Haskell. So yeah, really excited to chat to that. So interested to chat to that the other way around as well. But yeah, I don't know anything about Haskell's influence on Rust. I don't know if that's something that you know about or you want to just expand on a little bit.
Absolutely.
Yeah.
So there's a lot of functional programming influence on Rust. Rust originally, like, a bunch of OCaml folks worked on it. The original implementation was in OCaml. And so lots of functional programming influence there.
Hmm.
Many Rust developers have had background in functional languages, including Haskell. I wrote large scale production Haskell systems before I worked on Rust. Like, Haskell was my previous favorite programming language before Rust. Strong static typing almost to a fault.
Hmm.
Um, really interesting things you could do. Very different paradigm. It very much expanded my brain to work on. But on the other hand, when I worked on Haskell, the two things that always stressed me out were, one was, you run into a library, like, it's the perfect library for the job, and if you want documentation, it's right over here in someone's PhD thesis.
Hmm. Yeah.
And there's absolutely nothing wrong with that. It's like an exciting academic language, but it has that very strong, like, you know other people don't have to understand this. It's not wildly
Yeah.
approachable. And then the other aspect was, that mindset starts to become a little pervasive in your own writing. And when you start writing idiomatic, fluent Haskell,
Hmm.
it feels very like there's this constant pressure of, there must be a way to write this better or smaller or point free, or, like,
Mm.
there has to be a way to be more elegant, to push more of this in the type system, to check more stuff at compile time. The theoretical purity, the same thing that comes from, you can't do IO without declaring it as the IO monad,
Mhm.
also pervades in terms of you shouldn't be able to do anything that feels unsafe, like to a fault.
Mhm.
And I enjoyed that. I enjoyed the aspect of that, but I have a bit of a perfectionist streak, and Haskell would create that kind of analysis paralysis of, um, I don't want to start writing code because it might not be perfect.
Mhm.
And then I started working on Rust, and I found this, like, a lot of the functional programming stuff is there. We've got lambdas, we've got, or closures, we've got iterators, we've got first class functions in a lot of ways. And at the same time, there's also IO, and there's
Mhm.
also unsafe, and there's also, like, you can just write code. And so the flow rate of code when I'm writing Rust, I feel substantially more productive. I
Mm.
still enjoy Haskell. I love following the exciting developments that they're doing with what is the limit of how correct a type system can be,
Mhm.
and how much you can catch at compile time. And I think there's a lot of value in catching more things at compile time, and there's influence uh, that it does have. And we're always careful to balance how powerful can we make the type system on the one hand, and how complicated would that be on
Mhm.
the other hand. And we always want to balance that practicality, that learnability. I think we've found a good point in the spectrum, but we love listening to and hearing from other languages. We love working with people who are excited about Haskell. I know somebody who's
Mhm.
working on, like, joining the Haskell board to participate more with that, and
Yes.
who's also excited about Rust. Great cross pollination there.
What does your Rust personally look like? You talked about how you used to write everything like it was C, and then you're talking about your love of Haskell. What does, if you're writing Rust, do you write it in a functional way, or what's your preferred style?
Uh, I like to think it's reasonably rustic at this
Okay.
point, but I tend to use iterators and functional styles when I can,
Mhm.
but not to a fault. So,
Mhm.
like, I'll write a chain of 2 or 3 iterators, but if I'm getting into, 8 or 9 iterators, yeah, I'll just sit there and write a for loop. Like,
Yeah.
sometimes the right answer is just write a for loop. The pendulum has swung back the other way for me, for, like, because the compiler gives me so much feedback on whether my
Mhm.
code's correct, I'm more interested in make it work, make it actually shippable, and then I can always make it better later.
Mhm.
There's a let me oh, hang on. I think I
This is the last bit we'll do on this, just for everyone watching, and then we're going to switch up to talking a bit about some of the governance and stuff around Rust, which I think is quite interesting. Someone just asked on Twitch whether Rust is owned by Mozilla, so we're going to touch on that a little bit. And then I've now gone really big on the screen as Josh has dropped out. Get an insight into the overlays we have running on here. So while Josh just takes a break for a second, slash plugs his laptop back in. Yeah, we're going to talk a little bit about that, and then we're going to talk about features and roadmaps moving forward. There we go, Josh is back. So yeah, Josh. So
sorry about that.
first, that's all right. So
Oh, I just quickly finish the thought
yeah.
before I accidentally had laptop difficulties there. Um, there's a set of stickers going around for keep calm and call clone.
Okay.
And I think in general, there's a feeling like you can write Rust code that is very careful to never clone, never copy, always borrow, get all the lifetimes perfect, never use arc or similar.
Mm-hmm.
And you can do that. And sometimes you need to do that. But I think there's a tendency, because you can do that, to feel like you have to do that.
Mm.
So one big piece of advice I'd have for people who are getting started with Rust, or even people who are doing large scale production things in Rust, is treat that as an optimization step rather than
Mm-hmm.
as a you must do this from day one step. And if you have a bit of arc here, or a bit of RW lock there, or a bit of clone here, and your code works and it's performing well enough, then your
Mm-hmm.
code is fine.
Yeah.
And if you want to optimize it more later and possibly learn something in the process, it might be worth the effort. But if you're optimizing something that runs one time at startup of your program for half a millisecond, maybe it's not worth the time.
Yeah. Yeah, it's good advice. So you talked a little bit about obviously your journey into Rust and how you contributed and what that looked like, and the open source side. So um, I've got lots of experience of this from the sort of project lead point of view on something. You know, with Exercism, we have over 300 repositories on GitHub. It's a huge open source project, and we've really found open source challenging. We get, you know, tens of thousands of people want to contribute. Some of them come along and do what you did, where they spend a year learning everything, get really involved, and become, you know, critical members of the team. But we often get a lot of people that are just coming in with good intentions, but never then actually sort of follow through and do that work. I think we have that a lot as well as an educational platform. We're a place that a lot of people want to cut their teeth on open source. I imagine less people are cutting their teeth on contributing to the Rust compiler. But
Oh, you'd be surprised, honestly.
okay, right, yeah. But I think it's interesting just to look in general at how Rust is run as a project. You talked about at the very beginning how you're in multiple teams. Somebody asked, you know, is Rust owned by Mozilla? Obviously, there's been a lot of discussion recently around governance at Rust. There's this new constitution you've been working on really hard, and I know you're really proud of. Do you want to tell us a little bit about that story of that, the history of Rust and Mozilla and the teams?
Absolutely,
and,
yeah.
It'd be great to hear that.
So Rust started out as a side project by one person at Mozilla, Graydon, who wanted to build a programming language with certain properties and started working on it as very much a side thing, got a few more people involved in it, people got excited about it. And it was not an official Mozilla project at that point. It was just, you know, hey, here's something interesting I'm working on, which as a side note, I am really thankful also that Graydon had a lot of influence early on the building welcoming, inclusive communities and caring about how people work together. And that is a big part of where some of those original values came from and then have been compounded upon from there. But like if the first person driving a community doesn't have those values, they're not likely to select for having more people like that around them and similar. So I'm very thankful for that. That just is so wonderful. So it grew and it became surprisingly popular rapidly. And as people started getting more interested in it, more Mozilla folks realized, hey, we've actually got a thing here. We should give it some official support. More people got involved. At some point, Graydon ended up handing it off to others, and other people took the lead on it. There started to become a group of like, here's a handful of people who are driving the language forward, some of which were at Mozilla, not all, but some. And at that point, it was not that Rust was owned by Mozilla, but like any project started at a particular company where that company is the main one paying for people to work on it, it had a massive amount of influence from Mozilla. And then, of course, people were very excited when Mozilla started integrating it into Firefox, and it was tied into the, you know, this was right around the time Firefox did the huge marketing push for we're so much faster now, we're so much safer now. And a lot of that having to do with Rust drove interest in Rust. But then other people started getting excited about Rust outside of Mozilla and started getting involved. And more there were people involved in Rust's governance who weren't from Mozilla, and that was perfectly fine. And over time, the kind of here's one big team that drives Rust turned into, well, here's some people who are working on the language and some people who are working on the compiler, and it slowly evolved into a multi-team model. There was an RFC that came out later that codified that. It was a fairly simple RFC, and it mostly just said, okay, we should have multiple teams. Here's the first 5 or so of those teams. And that included things like moderation and language and developer tools, which incorporated things like cargo and Rust format and similar. And people got involved with those teams. People started working on that. And at that point, it was already the case that many non-Mozilla people were involved in the project, though it's still safe to say Mozilla was the biggest contributor. And then for a variety of reasons, ranging from Mozilla scaling back a little bit to many other companies and individuals getting involved with Rust, it kind of grew into more of a balance. And
Hmm.
that was around the time that Mozilla kicked off the effort to start the Rust Foundation, create a more neutral home for Rust that people can collaborate on. And for that matter, that was reflected in the language or the organization of the project, where more people were involved from not Mozilla than
Mm.
from Mozilla at that point. And from there, it has grown further, and we ran into scaling difficulties. So, like each round of this, it ran into scaling difficulties having one team doing everything. So, here, let's have a bunch of teams. Well, we ran into scaling difficulties having the minimalist structure of, okay, I guess there's a team for this,
Hmm.
and this. Like, it was a very minimal structure, just enough to get work done. And it ended up being that we ran into corner cases. We like to joke that we ran into some undefined behavior. And from there, we realized that we needed to create a more enduring structure, something
Hmm.
that could last the decades and not just the years. And uh, that turned into a conversation with the core team, a conversation with the foundation, a conversation with the moderation team on, like, what should this structure look like? And we ended up with a kind of interim governance that knew that it wanted to replace itself with its successors as soon as possible. But kind of,
Hmm.
we started out getting a lot more people talking with less formal structure, but more people involved, which
Hmm.
really helped to open up some conversations about what we needed to improve. We took a long time talking through that, working through some issues, figuring out input from everybody. We had some of the people involved had literally 50 plus meetings with different people trying to figure out all of the different input of what was needed
Hmm.
and what kinds of stresses and growing pains people were going throughout the project. And then we put together a team of 7 people from within that interim governance who particularly cared about policy making and structure and organization and similar. Um, and the 7 of us started building a document that started approximately last August. So we started drafting, we started putting things together, we divide and conquer, like, I'll take this section, you take that section. We
Hmm.
ended up with something that initially was something like 18,000 words, uh, cut it down, managed to get it down to around 12,000. Pretty excited about that.
Yeah.
But we ended up with something that's been published now that we're really excited about and that we think embodies a lot of the values of Rust and gives us a structure that is able to get more people involved, something
Mm.
that's more of a representative structure, something with plenty of rotation, get some fresh blood in
Hmm.
periodically, get some fresh ideas while preserving the need for experience, balance out the structure of, like, needs for moderation and safety and collaboration, needs to evolve. Like, we had no good way before of evolving the structure of the project. If
Hmm.
teams wanted to reorganize themselves, that would have been a year or two long process.
Right. Okay.
Now it can be much more straightforward to say, you know what, these teams want to join forces, this one wants to move under that one, doing that kind of thing to make room and to improve the structure is much more feasible. And
Mm.
at the end of the day, we now have a team, or we will have a team, that is able to speak for Rust when it has a need for a quick opinion on something, while also being representative of the whole Rust project. And I think
Mhm.
that's a huge improvement.
Entirely. It's really inspiring. I think the thing you said as well about balancing rotation and experience, I think, is such a critical thing. It's something we've talked a lot about, how you want to be bringing fresh blood and all of those things in, and you want to be bringing those people up, and also letting people leave in a really good way. Like, someone
Yeah,
doesn't want to be like, I'm going to do a bit of Rust now, I'm committed for the next 30 years to this, and that's a real
exactly.
challenge in open source.
There was a stigma attached to it, even like, if you leave a team, it's like end of an era and like all this work this person is
Yeah.
doing. And we did not do a very good job of dealing with what is jokingly called either lottery factor or bus number.
Yeah.
And we tended to not have much redundancy there.
Mhm.
But on top of that, people always felt guilty leaving, like, oh, I'm sorry, but burnout, and I just can't do
Hmm.
that anymore. And like, for this top level council, we want the opposite to be true of, like,
Mm.
it's perfectly healthy to get involved and then to later decide I want to rotate out and let other people do the
Hmm.
job. And this isn't a, you've taken a demotion, or you've been,
Hmm.
this is just like, I would like to let other people rotate in and work on it
Yeah.
for a while. Maybe I'll be back later. That feels healthy. And
Yeah.
it's not going to have a stigma attached to it. If it's, I've decided at the end of this year that I'm going to have somebody else rotate in as the representative for this team, that's healthy, that's normal, and nobody should stress about
There's
it.
no judgment associated with it. It's just a
Exactly. Yeah.
mature way of behaving. Awesome. That's really interesting. Thank you for talking us through all that. So I'd like to move on to the technical roadmap style section.
Absolutely.
You sent through earlier 3 links to me. Eric and Aaron are just going to post those into Twitch and YouTube for people watching now, so you can refer to those if you want to. Do you want to just give us a general sort of high-level overview on that roadmap? And then there's a few different questions coming in around this. Please do post questions if you've got them. Thanks.
Absolutely. So yeah, what I provided was the language, library, and compiler roadmaps, and some of the other teams have roadmaps as well. I was kind of posting those as examples that I knew how to
Mhm.
find very quickly. But these are kind of our high level goals for what we want to accomplish in Rust, and what we want to uh, where we want to take the language, where we want to
Mhm.
take the library, and what the common themes are for that. So, for example, the language roadmap was very much about how do we bring a bunch of like private capabilities we give to the standard library that aren't stable yet to the broader ecosystem? How do
Mhm.
we help Rust scale, help the ecosystem scale, help deal with problems where, for instance, um, because of some of our rules about where you can implement traits, it's
Mhm.
difficult to take crate A and crate B and create a new crate C that glue those two together.
Mhm.
You either have to add support for B to A or add support for A to B. We want to fix that. We want to make it so that you can uh, add a third crate that glues the two together. And there's 100 more things like that. I definitely recommend reading the roadmaps, both if you
Mhm.
want to get an idea of where we're taking the language, as well as if you want to get an idea of, hey, that sounds exciting and I care about that and I want to contribute on that, or I at least want to have a conversation with the people doing it and figure out if they're solving the thing that I care about.
Yeah.
Very much excited to do that kind of thing.
If
And
people have their own like questions and ideas, is posting like issues on GitHub the way that is that like your preferred way as a team of sort of
Zulip,
exploring roadmap?
actually. Yep. Zulip is the best place to
Zulip.
take that. So Zulip is our development chat system.
Mhm.
It's been a huge improvement over past systems. It has threading in it. So like you can go to the language stream on Zulip, and there are a bunch of sections with um, subjects, and you can start a new thread and have a conversation.
Mhm.
There are like the language roadmap links to a roadmap discussion stream that you can start a thread, and if you want to
Nice.
talk about there, you can bring library things to the tlibs Zulip stream, and we're always happy to talk about possibilities there,
Okay.
and what problem you're trying to solve as well as what you're looking to do. And it's always about like, we're not looking to add everything, but we're looking to support every use case.
Mm.
And how much can we do with how little is a big goal there. Can we add a few orthogonal features that cover a huge number of use cases?
Yeah.
One philosophy I've had is very much, there are two kinds of languages that are continuing to add new things to cover new use cases, and languages that are in the process of dying.
Mm. Nice.
And
Yeah.
like, I don't mean, I am, this is not a commentary on any particular language. I am a
Mhm.
big fan of like let a thousand flowers bloom. I don't
Mhm.
like talking about other languages negatively. I'm just saying, like, sometimes it's a decision to, we want stability long term for all the people who currently use it.
Mhm.
Sometimes it is, we want to add things to encourage more people to use it and to cover more use cases.
Mm.
And we are trying to balance both, of saying we always want to cover new use cases, we also care about all our existing users, and this is one of the reasons we have these rock solid stability guarantees for, we
Yeah.
will not break your code.
It's interesting. So when I chatted to Jose Jose Valim, creator of Elixir, a few weeks ago, he was saying that his decisions are always to try and keep Elixir as small as possible, but
Right.
facilitating every use case. So if there's, Elixir should be almost as complete as possible in terms of anyone can do anything in it, but he doesn't want to build that functionality into the core library or the standard library, but he wants to make
Absolutely.
sure there's nothing that you can't do with it. And often, we were talking a bit about the new, I don't know if you've seen, but numerical Elixir, which is doing sort of machine learning stuff in Elixir. And his, there were certain things in there that made it necessary for like tweaks to the main language and things. And
Right. Makes sense.
seeing those sorts of things, I think what you said there about use cases is I find the same when someone opens an issue at Exercism. It's like, don't tell us what you want to do unless you're also telling us what the problem is that's solving, because often that's the sort of that's the key bit that actually is the blindness that we have. Is not, we don't know what everyone wants to do. We need you to sort of open our eyes and tell us all of these
Absolutely.
things. So
that's actually something I would encourage for Rust as well. Like, if the ones that go over least well are like, I want this feature from another language, or I want this feature and I'm not telling you why. The ones that go over best are, I have this problem. I think something maybe this shape might solve that problem. Can we have a conversation? And those end anywhere from, have you tried this feature, to, yeah, that sounds like something that might work, to, well, we're not excited about that way of doing it, but we care about you and your use case. Here's another way we could do it. And I love how that works.
I love that. Yeah, I totally agree. I think I see that on Exercism's forums all the time. When someone shapes a question like that, there's so much positivity that is an immediate response to that post. Whereas if someone comes in just suggesting a feature without really explaining any of the context, it's often met with not hostility, but it's met with a lot more resistance because you feel context blind.
Exactly, because if we can't see the use case, we're more likely to weight this adds complexity.
Exactly.
Absolutely.
Yeah. You talked a bit there about, posting thoughts. Are there any other tips in general for people who want to get started contributing to the language?
Absolutely,
is there anything else you'd recommend?
So there's one kind of community and philosophy difference that I've really found wonderful and that I would recommend. So there is this kind of negative feedback cycle that many aspects of tech have, where, like, in order to be heard, you have to be coming across as a certain level of confident, almost to a level of overconfident, because, like, otherwise somebody else will come in and override that. And that's a negative cycle, because then, okay, well, in order to be heard, I have to be at least that confident, and then I have to be more, and then I have to be more. And sooner or later, you can't tell how much people actually believe in something, how sure they are about something. Nobody feels like they can say, I don't know, because then they'll, well, I know, and then they'll just get stomped on. Rust makes a conscious effort to avoid that, to the point where you will get a great deal of positive, safe reception for, I'm not sure, I don't know, maybe something like this. Like, it's not that you should undersell it, it's that you should give an accurate idea of how confident you are or aren't. I do this all the time, even in a language meeting about a language feature. I will be, hey, I don't fully understand exactly how that works. This expert does. Could you give us more information about that? So approaching it from a perspective of, it's safe to express that you're not sure, that you don't know, but here's some ideas you have that might work. Here's a use case you have. You're not quite sure how to solve it. That is always going to get you a much more positive response than, I know exactly what you should do, and if you would only listen to me. We get a few of those every once in a while for like, you have no idea how to do object-oriented programming, but I can teach you. Like, bye.
There's that the bravery, but the culture where just saying I don't know is actually like, it's like the thing that everyone holds in the highest regard, I think is
it's super scary before you realize it'll be safe. And in Rust, we put a huge amount of effort into making that the right thing to do, and that avoids that vicious cycle where we can never calibrate to accurate. We have to calibrate to blowhard.
And I think as well, I always see it as a sign of capability. When you don't feel the need to be proving yourself in a conversation, there's a contributor to Exercism, Peter Teng, who's I don't know if you know him. He's one of our Rust maintainers, but he's like second in the all-time Advent of Code leaderboard. Like
Nice.
the guy is, incredibly smart. But he's the most humble person, and he never says anything if he's not sure. He's always willing to just communicate uncertainty, and he's therefore just a permanent pleasure to work with. I've not come across anyone that doesn't enjoy working with him, but most people I know think of him as the smartest person in any room, sort of thing. And I think it's that. I often think that the more capable and smart you are, the more you're probably likely to be willing to say, I don't know. And I think it's such a powerful skill to learn, but I think you have to design a community. And I use the word
Yeah.
design there. You have to design a community where saying I don't know is the optimal behavior, where you're all willing to opt into that.
And you have to give examples of it as well. You have to
Yeah.
see the senior people doing it, but you
Yeah.
also, like, it's not enough to just see the senior people saying, I don't know, because then that comes across as, well, it's okay for them because nobody's going to doubt they're an expert.
Yeah.
You also have to see more junior people going, I don't know, and not getting stepped on for it and getting a positive response. And like, the more we can reinforce that, the better.
100%. Another question, there's a few questions coming in that we can go through, but one that just came in that I think is quite interesting is, do you sometimes feel the need to introduce a Rust 2.0 that would break compatibility to achieve things that were impossible with Rust 1?
So I will freely say, like, we've all got the joking list of like things I would do over again if Rust were pre 1.0.
Yeah.
We all have that list. And at the same time, the Rust edition system that was introduced around like 2017, 2018 is one of the most unique approaches I've ever seen to handling that has really substantially reduced the desire to ever do a 2.0.
Yeah.
So we have the ability to say your Rust code today will work forever. And also, here's a new syntax that you could use in this one area that makes things work a little bit better. Here's a better module system that's more intuitive, but the old one still works. Here is a new keyword, but we're not breaking any of the people who used that as a variable name in the past. And this really has almost eliminated any desire to have a Rust 2.0 on the language side. It has been a little bit of a challenge to get the full benefit of additions on the library side, because at the end of the day, you can sort of do that. You could introduce a new version of a function in a new edition, but at the same time, you have to be interoperable. Hashmap is hashmap is hashmap in any edition. And you can't change the layout of a type, for example, or other things like that. And there are some things we could do. There are some things we can't. So we're looking for more ways to expand that and to have more things we can do with an edition. And I hope that we find good ways to do that. But like Rust 2.0 will not happen on my watch.
Okay, nice.
That I do not like the idea of. We've all. I'm not picking on Python here. I love Python as a language, but Python 3 is our standard example of we are not doing this.
Yeah.
And
we have the same with Perl and Raku as well. It's
absolutely. Which, like, Perl 6 is a really interesting language. I really loved following Larry Wall's posts on that as it was developing, but like it was such a revolutionary change that it was difficult to, Perl 5 is going to live forever at this point.
Yeah.
I think if Python had it to do over again with like the current state of the industry and seeing how things were, I wonder if they would have done something more like the addition mechanism of we have one interpreter, it parses Python 2 and Python 3. The language is interoperable. You can import a 3 from a 2 or vice versa. You can incrementally port. And like there are a few things that would have been harder. Like it would have been harder to do the they did a bunch of things about method resolution and inheritance that were different, and so it wouldn't have been trivial, but I think it would have been worth the design difficulty, at least for the surface level language and dialect, to make it completely interoperable. I think that would have led to a much bigger transition and a much more powerful Python ecosystem now and less of a division between kind of the old enterprise stuff that's still on 2 and the new exciting stuff that's ported to 3.
Yeah. Yeah, I totally agree. Your opinion on the current vision laid out by the Keyword Generics Initiative?
That's a great question. We have been having a lot of conversations about that one lately. So, for context, for anybody who's not familiar with it, keyword generics are a means of saying I can write one function, and that is both async and not async. And if you call it from an async context, it's async. If you call it from a sync context, it's sync. And we were talking about doing the same thing for const, like this function can be done at compile time or runtime, but you don't have to write it twice, that kind of thing. And on the one hand, it's really exciting, the idea of a library that works just as well in a sync or async context. And we like the idea of not having code duplication. And on the other hand, this would be a substantial complexity increase to the language.
Yeah.
And this is one of the best examples of that tension lately of balancing out complexity with the desire for covering use cases. And in my opinion, I am not the foremost expert in that area. I am working with those folks, but I am like other people are driving it. But in my opinion, I don't think we've quite found that balance yet. I think we're still a little too close to the complexity side for my taste with a language team hat on. But I also really want to see the problem solved.
Okay.
And I am wondering if we either can focus the complexity more in just the areas of like those who need it deal with it and those who don't need the complexity don't have to deal with it, or find a simpler expression of it that will get us 80% of the value with 20% of the complexity. And if we can't, then we may have a much harder decision to make, and I'm not sure what it will look like. But I'm excited about the possibility of more pervasive integration of async, more pervasive integration of const, and similar.
Nice. Thank you. Another question. Could you talk about the roadmap for integrating async and await into the standard library?
Absolutely, yeah. So we integrated them at the language level a number of years ago. This was around 2018. But from a library perspective, we put kind of the bare minimum needed to drive futures. We have the future trait, we have a few key functions, we have the context mechanism for like how futures are glued together. Enough that like the language has enough library stuff to hook into to actually represent those. What we don't have async read, async write, async seek. We don't have IO. We don't have file objects. We don't have channels. We don't have asynchronous versions of mutexes. We don't have an executor or what's commonly called a runtime that like the role that something like async std or small typically fulfills. And that's true for a variety of reasons. One is the Rust standard library has much stronger stability guarantees. We can't afford to break compatibility. Once we've added it, we're committed to it. There's a reason why multiple languages have sometimes said like their standard library is where code goes to die, in the sense that like it will never evolve further. It is difficult to improve, and then you see, oh well, you shouldn't use the thing in the standard library. You should go use this third party thing, and that's not a space we want to be in. So we've taken our time trying to integrate that with the hopes of like we should have an executor trait that different executors can implement, and then here's a default executor in the standard library that works for 70-80% of people. And if that doesn't work for you, well, go grab small, go grab async std, go grab Tokyo, but it'll still work with all of that code. We're all really sad about the current state of the async ecosystem being kind of partitioned. We're like, here's a library that works with Tokyo, here's a library that works with async std, and or alternatively, here's a library that works with both, but it has twice as much code, lots of manual feature flags, and its own abstractions, and they're redoing the work the standard library should be doing for them. So the first thing I expect to see happen in the standard library is the IO traits. We're going to
Okay.
try to get async read and async write so that you can write things like an asynchronous file or an asynchronous channel or similar in a way that doesn't require you to care which runtime you're going to run on. And then we are eventually going to get to having an executor in the standard library and an executor abstraction and similar. And that's going to need some new language features, I think, as well. That's not a purely library change. We need a language mechanism for that kind of, I have this global resource, the executor, that I want to interface to, and I also might want to sub it out. Like, people today can write, async std, except I'm dropping into Tokyo over here for this one library that only speaks. Like, I have a large code base today that does that. It's primarily using async std, but it calls the AWS SDK, which currently takes a lot of manual work to glue in support for async std. I hope it gets there. But right now it requires Tokyo. So that one part substitutes in Tokyo, and those interoperate just fine. But it's certainly, I'm not thrilled with the fact that I have 430 dependencies in my dependency tree. So we're going to add that interoperability. We're going to make it so that if you don't care which runtime you're on, you can just write your code once, not twice or three times. And at the same time, if you do care, you can say, well, this is the one I want to use, and this is the tools I'm using to work with that. And maybe one day we will get to the point where, like, well, I want to run async std, but I also really love this Tokyo tracing framework that lets me, pop up a top-like thing and see all my futures. And like, hey, these two things just beautifully work together. I hope we get to that point in the future. It's going to be a few years, but like incremental years. It's not, let's wait a few years and it'll happen. It's, we expect to get IO traits soon, and then executors after that, and then more things after that.
Incremental improvements. Cool.
Exactly. Yeah.
Great answer. Thanks. Another question. What's the status of stabilizing support for using the alloc crate in a non-standard program? The person says, if they understand correctly, the current blocker is that alloc error handle isn't stable.
So great news on that front. We actually just stabilized, not the full alloc error handler if you want to have an arbitrary one, but the default alloc handler is now a stable default mechanism, which means if you don't need to change the alloc error handler, if you're happy with the panic unwind or panic abort behavior, whichever one you prefer, then you can just use the alloc crate from entirely stable code. The alloc error handler itself does still need stabilizing for people who have more exotic needs and need to specify exactly how that works. And I'm hoping we will stabilize that in the future. But I think the broad spectrum use case of being able to use it at all is now stable. We just shipped that within the last couple of weeks.
Nice. Awesome. Next question. Is Polonius, I don't know what Polonius is Polonius being actively worked on? Has it been put on the back burner? And if so, is that as a timeline or is that indefinite?
So Polonius is the new borrow checker, or really the new borrow checker that people are really excited about. So a while ago, around 2018, there was an effort called NLL, which was non-lexical lifetimes. And this was the idea of, rather than this lifetime always lasts to the end of the scope, that instead you can say, well, I borrowed this and then I stopped using it here, and then right after that in the same block I started doing something else that would otherwise conflict with it. And the borrow checker can now see, well, you never actually use them at the same time, so that's fine. And Polonius is the next step past that, of making the compiler even smarter, making it so you have to fight it even less, and in general making it so that you don't find yourself going, hey, compiler, I'm really not borrowing these in a way that conflicts. Can't you see that? And that's really what it grew out of, was couldn't you just see that? Well, yeah, we could teach it to see that. And we always like making the compiler smarter like that. It is being actively worked on. It's had periods, it has had lulls, and then it's had really active periods. Right now, there's some people really excited about it. I don't know what the exact timeline is. Right now, the Polonius is, at this point, basically feature correct. Like, it works. It's available in Nightly. You can pass -z Polonius and get it to work, and it works great, except for the fact that it's incredibly slow.
Right.
And so its primary issue at this point is, can we keep its smarts and make it fast enough that we are not substantially slowing down Rust compilation times?
Mm.
And that has been the challenge. A lot of the people involved believe the answer is yes, we absolutely can, but that's going to take time.
Yeah.
And we're all aware that Rust compilation times are a factor, and we're always trying to make that faster via a variety of paths. We're making the compiler faster, we're making the tooling faster. Somebody just revived the parallel rustc effort, so that
Mhm.
like that last rustc compile that's normally single threaded, it's just compiling your top level crate, can actually split out and say, oh hey, you've got 16 CPUs, great, I'll use them all.
Mhm.
And this is actually personally the business that I'm working on as
Mhm.
well, is I'm building a service for building software faster.
Mm.
And this is partly inspired by Rust, partly inspired by the Linux kernel, but very
Mm.
much like, can I take a 5-minute build and make it take 30 seconds by running it fast in the cloud?
Nice.
So yeah, compilation time is a critical factor there, and nobody wants to make Rust substantially slower. So
No.
that is the blocker on Polonius. It's not that, oh, we're still debugging it, it's not quite correct yet. It's pretty much correct. It's not fast enough.
Is it written in Rust, or is it written in something else? Someone asked in the chat.
So there have been a variety of experiments in this area.
Mhm.
People have done experiments in other languages. People have built type system logic and borrow checker logic in like logic programming languages and
Mhm.
similar. Some people have done experiments in Datalog. The actual implementation of Polonius is in the compiler in Rust,
Uh-huh.
but people have done all sorts of experiments that are in other languages and use that for prototyping, or even
Okay.
considered the possibility of if it could fit into the language that way.
Right. Um, Good question here. Which, if there is one feature from another language that you would like to borrow or bring into Rust, what would that feature be?
That's a great question. Um, right now, the I think I would say there's two from different languages.
Hmm.
One is that I'm really excited about generators. It's a
Hmm.
real pain to write iterators by hand, and it would
Hmm.
be really wonderful to just write a for loop with a yield and have that turn into an iterator,
Hmm.
and transparently interoperate between for loops, iterators, and for that matter, async support.
Hmm.
So async iterators, sometimes called streams, should work just as well with that. So I'm excited about that. I think it's a small surface area to add to the language. We're already kind of 3/4 there with async, and it's just a matter of having the right surface syntax and similar for it.
Hmm.
The other is I've been really impressed with Zig's degree of interoperability with
Hmm.
C. The ability to just include a C header, call C functions, and it just works. Like
Hmm.
Rust touts its interoperability with C, and we have some great interoperability with C at a like capabilities perspective, but you're
Mm.
still writing, either handwriting a lot of declarations or using tools like bindgen and cbindgen.
Hmm.
I would love to invoke the Rust compiler, hand it a C program, a C file and a Rust file, and have both of them call functions from the other in both directions
Hmm.
completely transparently with no glue.
Nice.
And then the only glue you have to write is, well, I want to make a safe wrapper around the unsafe interface.
Hmm.
I want that to be completely transparent,
Mm.
completely interoperable. I want you to be able to take a large established Rust C project and just add one Rust source file and an invocation of the Rust compiler, and not feel like you need to introduce tooling like bindgen and cbindgen to make
Hmm.
that interoperable. Not feel like you have to make, like right now, it's a crate boundary. You have to build a library that exports an interface, and you can't both export and consume an interface from the same other pseudo crate that the C is in.
Yeah.
I want to do interoperability at the level of include this header file and call the functions in it.
Uh-huh.
And given that like Rust's two biggest backends are LOVM and GCC. There's an
Hmm.
LOVM backend that's what everybody uses every day, and there's a GCC backend, Rust C CodeGen GCC, that's up and coming that we're really
Hmm.
excited about.
Yes.
Both of those have a C compiler in them.
Right.
There's really no good reason we couldn't invoke the C parser, invoke the C preprocessor, pull all that information in, and just be a portable C compiler.
Hmm.
It's a huge undertaking. It's a major project. I'm really excited about it. I look forward to mentoring anybody who's wanting to work on that and helping them drive that forward. I don't have the bandwidth to like drive it single-handedly, but I
Mhm.
will happily collaborate with anybody who wants to work on that one, who's excited about that.
Nice. We're chatting to, I think it's the creator of Zig or somebody in the core team as well, hopefully in the coming weeks as well. We've agreed to interview, we just need to get a date. So,
Awesome.
yeah, it'll be interesting to chat a little bit about that as well and, discuss the decisions they went through. A question from me. So, you talked about how good it is to have lots of different languages doing lots of different things. Are there any languages out there that you've not really dug into yet, but that you're interested in or excited to dig into? Anything on your radar or something you want to learn in the next or explore in the next year?
It's a great question. I honestly expect over the course of the next year, the biggest one for me is going to be the the breadth of build system
Mm,
languages out there. So, like, I know Make. I have reluctantly dealt with CMake. I have dealt a little bit with a few other things, but there are things like I don't know if it's called scons or scons.
mhm,
There is Meson. There are like 50 other build system languages out there.
mhm,
There's also the language whose name is escaping me that is what Google created as kind of a small subset of Python that they use in Bazel.
I can't
Um,
remember.
yeah, I'll remember it 5 minutes after this
Yeah.
interview. But uh, there are all of these languages that are designed for that kind of glue,
Mhm,
and I think it's really interesting how many of them there are. I think
mhm,
that there's a lot of opportunity to make those better
mhm,
in terms of both interoperability between them, as well as things like rather than spawn a program locally, what about doing distributed builds? Could you
mhm,
teach those languages to distribute things over 20 systems to build faster?
mhm,
So I want to get into more the breadth of build system technologies. I've already looked at a lot of them. I'm going to be looking at a lot more. The long Starlark, that's the one. Thank you. Somebody in the chat provided that. But yeah, there's 100 things out there. There's as many build system languages as there are programming languages,
mhm,
and they often don't get as much love as a programming
mhm,
language other than the ones that just directly embed a programming language. And
mhm.
I think that there's room for doing better there.
That makes sense.
And I don't
Um,
just mean like, oh, let me give my entry and my take on that. I mean, like, I think there's room for the existing ones to provide more like library and plugin and
mhm.
extension functionality to be interoperable as well.
Um, yeah, makes a lot of sense. It's not quite the same, but it's been interesting. We've added tracks on things like JQ and stuff recently, which build
Mm.
languages are languages that are often used in the process of that, and
Oh
it's
yeah,
been really interesting. Like JQ's been a really cool track. Like it's Turing complete. You can solve any exercise exercise in it, and we've gone from taking a bit of JSON parsing to suddenly like being able to write anything in there, and that's been a really
absolutely.
fun thing. Yeah.
Do you have like a regex track or a
No, we don't. It's something we've talked about before. That there's so many good regex things out there that we've sort of never really wanted to invest in it, and no one's ever really
That's
taken it
valid.
up. But if anyone wants to write a regex track for Exercism, again, it's something that as long as you can solve all the exercises in there, it would be well up for it. It'd be fun. Somebody asks if you've read the Without Boats blog post called "The Registers of Rust."
I have, yeah. I thought that was a really interesting post.
Okay.
So for people who haven't seen it, the premise is not registers in the sense of like the CPU registers. This
Hmm.
was more what register you're switching to, like in a linguistic sense.
Hmm.
People who talk formally in one context and who talk with a dialect in another context, like code switching, cultural things, that kind of thing.
Hmm.
And the premise here was that programming languages have the same thing, where you have the Rust that you write in in a like a micro server, and the Rust that you write in an async context, and the Rust that you write in low level systems glue and kernels and
Hmm.
all of that kind of thing. And I think there's a lot of validity to that. I think one of Rust's strengths is that it can do all of those things, and I think we want to minimize the necessary divergence between um, dialects of Rust, in that we don't want to have, oh, here's a construct that only makes sense for this one but makes that one more painful, but you have to learn them all. Down that road lies like languages that are trying to be everything for everybody. And we do want to solve every use case, but we don't want to be so complicated that we're not very good at any of them.
Yeah.
And so um, I think there's a huge balance to be had there. And I think that much as with human languages, where like you can get very playful by combining those different dialects and those different registers that you might be in, and kind of use one in an unexpected context where you'd expect the other. There's a lot of playfulness to be had with Rust where you mix those dialects, and there's a lot of productivity to be had of like, well, you know what? I'm writing an asynchronous server that needs to run inside of a kernel. I have both needs. Like, these dialects will cross-pollinate. They don't have bright lines between them, and that's one of the reasons we don't want to have bright lines of, oh, this only makes sense for that dialect. But I also really appreciate the concept of orthogonality, and that blog post made a big point of like, here's a bunch of things you might care about, and here's a bunch of things you might care about. Which entries in this table don't exist, and should they? And we're never gonna like just complete the table for the sake of completing the table if there's no like use case to say why. But we absolutely do that kind of exercise all the time to say we'd much rather add a feature that is orthogonal, that interoperates with all the other language features, and that all of those interoperations make sense, rather than a special case thing that only works over here. So I love the idea of adding generators. I love the idea of integrating those with the language to the point where you can write them as a for loop, you can write them as a closure. There's an idea that I've had, like several of us on the Lang team have had floating around for a long time, of like, without adding too much complexity, can we integrate control flow and closures so that you can use, question mark inside of a closure without, like, you can bubble the error out to your outer function without having to like have 3 levels deep of, I need to question mark here, and then I use the try variant of this iterator function, and then put a question mark on that, and then do this. That can we just teach closures that they can do kind of call CC, or the equivalent of I want to do a non-local return, while at the same time, like, if you want to ask somebody what the most terrifying feature of C is, and really that's a high bar. But like, set jump, long jump would be one of people's top candidates across the board. That, or signal handling, which is kind of more of a Unix thing than a C thing, but they kind of go hand in hand. And we don't want to go anywhere near that. We want to build something that is not exciting, that works in the most obvious way, that is kind of declared. And that's one of the reasons why one of the many keyword generics things might come into play there, where can you write one function that works whether you are try or not try, whether you're returning errors or not, and just say, well, however they want to return an error, this is what needs to happen in my function before an error is returned. And that would make it possible, instead of having to say, oh, well, I guess I have to switch from collect to try collect or similar, you just run code and it does the right thing.
Yeah. Really interesting. That was a really interesting answer. Thank you. I'll take a look at the blog post. I don't know if it's been posted into the chat, but if not, maybe someone could post the link into the Twitch and YouTube streams. Okay, I think last question then, Josh, and I think our time is up. All right. From Aaron, who I know has passionately been learning Rust recently and is really excited about that journey. He asks, how long did it take you to be productive in Rust, and was there anything that you found particularly hard in that journey?
Sure. So I would say it was probably a couple of months before I felt like Rust was more of a conversation and less of a conflict with the compiler. And that was the point where I felt like, okay, I can do pretty much anything I could do before.
Right.
But then it's been a long journey after that for like learning async, for example, is something I didn't really get into until a few years ago. And it helped to write a large production async program and kind of figure that out for the first time. I think a big part of that was like I had a bit of the same analysis paralysis of like, but which runtime do I pick, and like what should I go with, and what if I make the wrong choice and integrate it throughout my program? But I also think a big part of that was right now there's still big parts of async that you have to do manually. One of the design goals of the work that we're doing on async now and some of the async working group stuff and similar is right now, if you want to write like a read or a write implementation, you end up with things like pin all over the place. And what we're going for is pin and poll, really. And what we're going for is more a model of if you see pin or poll, you've probably gone too deep. You should be able to write everything with async fin, and this is just the underlying mechanism that desugars to. That's actually a concept that comes up in Rust generally, and you might hear the term desugaring. The premise is here's a high-level construct, and here's the thing it really means. Like async fin, you're writing an async function, and what that really means is you're writing a function that returns a future. And you can write anything you could with async fin using futures directly, but it's going to be a little bit more painful, and the syntax sugar makes it nicer. So we're hoping to make it so that sugar is more pervasive, that you can read and write by writing async fin read rather than writing fin poll read returning pin poll something or other. That makes it much less painful to say, oh, I have this special thing I want to glue together. I want to put a wrapper around a temp file to create this interesting stream object, that kind of thing. So on the one hand, a couple of months, and on the other hand, still today. It depends on which aspects of it you're looking at. There are portions of the type system that I am not an expert in, but that other people are, and I lean more on them. There are parts of low-level programming in Rust that I'm more familiar with than a lot of people, like assembly and linking and similar, and the some of the nuances of cargo and build scripts. And it's all a trade-off. But at the same time, we don't want to be the kind of language where you like, oh, you're going to have to pick a subset because it's too big for anybody to learn all of. Rust is not too big for somebody to learn 100% of. And like, I feel like I'm 70-80% of the way there at this point. And it is something where we don't want the language to grow without bound, but we do want its growth to encompass the use cases of everybody in the programming world. There shouldn't be ever a task where you say, I can't use Rust for this. That doesn't mean you must use Rust for it. We'll be excited if you do. But the point is, if you say, I want to use Rust for it, we're there for you, and we want to support you.
Really interesting. I love the fact that you have been writing Rust for a while and that you are a member of the language team, but still only know 80% of it, and still have as a goal to learn 100%. I like both sides of that: the sort of humility that you know 80%, and the at the same time the aspiration. I should add as well that Isaac in the chat points out that we don't have a regex track, but we do have an awk track, which
nice.
is pretty on the way. Yeah. Awesome. Well, I think our time is up. That was a really fun chat. Thank you, Josh. I really appreciate your time. Thank you to everyone that's contributed and asked questions in Twitch and YouTube and watched, and to all those in the future who are watching this back as well. We've got some more really exciting interviews coming up with creator of C++, Simon Peyton Jones of Haskell fame as well. A few more bubbling away. So please keep your eyes open. Everyone in the chat thanks you for all of your answers as well, Josh, just so you know, if you can't
I appreciate it. Thank you very much for having me, Jeremy, and a very good luck to everybody learning Rust by any means, including if you learn it via Exercism. Good luck, and we look forward to seeing you in Rust.
Awesome. Thank you. Have a great evening, everyone. Thanks.